Section 2.4 is talking all about complex numbers. And all that a complex number is kind of a whole number mixed with an imaginary number, or sometimes just an imaginary number. So what I'm going to do first is just try to remind you guys about imaginary numbers. Okay, so this is like the square root of -1. This, don't forget, is called I. I stands for imaginary number, which is the square root of -1. Since this doesn't really exist in the plane of what we know, so we call it an imaginary number. It does matter. It does have a value in real life, but we just can't really see it with our eye. Kind of like an imaginary friend, you know? Like my best friend growing up, because we all know I had so many friends. Ha! So, with I is -1, well, I squared, if I look at that, that's the same thing as saying the square root of -1 squared. Well, when I square the square root, I kind of just drop it, so I squared is -1. That will be helpful, very, 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 very helpful when you guys start working stuff out. If you want to look at, say, I to the third, that's the same thing as saying I squared times I. So really, this is going to be -1 times the square root of -1, which is just -I, and I to the fourth is I squared times I squared, which is the same thing as saying -1 times -1. So I to the fourth is 1, and then we go to I to the fifth, and this is where our pattern kind of repeats itself, because this is I squared times I squared times I. We know these two make a +1. I is just I, so I to the fifth is just like I, which is square root of -1. So really, as long as you guys are really comfortable with these four, and especially these two, then you guys won't have any problems with imaginary numbers or complex numbers. Okay, something about complex numbers that is just true, and we know it has to happen, is they happen in conjugate pairs. Don't forget, if you had a fraction like 3 over x minus 4 and you want to get rid of this, your conjugate was just the opposite sign. We would multiply by x plus 4 over x plus 4. Right, these are called conjugate pairs. Conjugate pairs happen when basically you're going to change the sign in front of the I, the imaginary number, wherever it is. So if we know that x equals 2 plus 1, or 2 plus I, then also x equals 2 minus I. Notice how the signs just switched. One's positive, one's negative. If x equals 3 plus 2i, then also x is 3 minus 2i. If one 0 is 3i plus 2, then another is negative 3i plus 2. Right? They happen in conjugate pairs, so basically whatever sign you have in front of your I, in order to get another one, we have to just change the sign. If it's plus, you make it a minus. If it's minus, you make it a plus. That one's a positive, so I also made that one a negative. If we had 3 minus 2i, then another one would be 3 plus 2i. This is going to be very important. It may give you, and say 1 0 is this, find the other 3. Well, then really it gave us 2 zeros. Okay, but we'll talk about that in just a second. The majority of the problems that you're going to be seeing in this section, however, are just going to be talking about simplifying the complex numbers. So really, if I want to simplify, all I'm doing is adding and subtracting, multiplying, dividing, just like we would when we're simplifying 3 plus 4 is 7 or something like that. Okay, so I'm just going to be combining like terms. In this case, however, I notice that my negative needs to distribute to both terms. So this is the same thing as saying 8 minus I. Distribute your negative, so minus 4 plus I. Then I notice negative I plus I is 0, so 8 minus 4 is 4. So your answer would just be 4. Here's another example of a simplifying problem with subtraction, but it looks a little bit different because I have not pulled out my negative. Don't forget, the square root of -1 is our I, so I know I'm going to have to pull out an I from that square root. But also 18 will break down into 2 and 9, which will break down into 3 and 3, so I can pull out a pair of 3's and I'm left with a 2 on the inside. So this is saying the same thing as 8 plus, pull out your 3's, pull out your I, square root 2 is left on the inside, and I. And then minus 4 plus 3 root 2I. Okay, then it's just like the last one, where all we need to really do is distribute the negative to both terms, and we have 8 plus 3 square root 2I over there, minus 4 minus 3 square root 2I. Once again, this won't always be the case, so don't just think every single simplified problem is 4. 3 square root 2I minus 3 square root 2I is 0. 8 minus 4, hey, we get 4 again. 4 is a really happy number, apparently. You're also going to see problems like this where you need to simplify, but notice this is just straight up multiplication, so you're going to need to distribute the 1 to both terms. So when we do that, we'll have 1 times 3 is 3, 1 times negative 2I is minus 2I, and then distribute the I to both terms. So I to the 3 and to the negative 2I. I times 3 is plus 3I. I times negative 2I is minus 2I squared. And here's where I said the rules were very important, because this I squared, don't forget, that's negative 1. So really, I have 3 minus 2I plus 3I is plus I, minus 2 times negative 1, because I squared is negative 1, so I'm just saying I squared is negative 1, just substituting it in for that. So then negative 2 times negative 1 is 3 plus I plus 2. Well then, 3 plus 2 is 5, so I'm just left with 5 plus I. That's as far as it'll go. Here's another simplifying problem where all we're really doing is multiplying. Okay, so I'm going to multiply the 6I to both terms. So 6 times 5 is 30I. 6 times negative 2 is minus 12I squared, since you have an I and an I. Once again, we have an I squared term. So once again, that's going to be negative 1. So really, I have 30I minus 12 times negative 1. 12 times negative 1 is 12, so this is 30I plus 12. And there it is. Last type of problems that you're going to kind of see here are writing the quotient in standard form, or just writing your whatever it gives you into a complex number standard form. Standard form for complex numbers is just like a plus or minus bi, whatever it is. A is a whole number, b is a whole number. Hopefully this should be pretty simple to get it to it. With this one, I notice I have an I on bottom. Well, in order to get rid of that I on bottom, if I multiply by I, because I know that I squared is equal to negative 1, then I'll have a negative 1 on bottom. So what I do to the bottom, I must do to the top. So then multiply both of them by I. So 5I on top over I squared, which I know is negative 1. So this is the same thing as 5I. Come on. 5I divided by negative 1, which is the same thing as negative 5I. That's all I need to see. There it is in standard form. Ones like this are a little bit trickier though. Okay, I notice I have two numbers on bottom, so I need to really figure out a way to get rid of that I on bottom. Well, I know I squared is negative 1, so if I multiply by the conjugate, it will make that go away. We'll work it out and I'll show you. So I multiply by the conjugate, so the only difference is the sign in front of the I. So now on top, I will have distribute the 2, so 8 plus 10I over, now when you multiply the 4, you got to distribute the 4 to both, as well as the negative 5I to both of those terms. So 4 will be 16 times 5I is plus 20I. Now when I move to negative 5I times 4, it's minus 20I. Negative 5 times 5 is minus 25I squared. So here's the good thing, because this is basically a difference of squares, my middle terms kind of cancel each other out. 20I minus 20I is 0, so I kind of lose my middle terms. I know that I squared is negative 1, So I have essentially gotten rid of the i's on bottom. So 8 plus 10i is still on top, over 16 minus 25 times negative 1. So really all this is 8 plus 10i over 16 plus 25, and simplify. So 8 over plus 10i over, what is that, 41? And there it is. I have gotten rid of the i's on bottom, and that's all I need to do. Okay, this last one I'm going to look at for your 2.4 notes. In order to get rid of this I on bottom, this one is just a matter of multiplying both top and bottom by I. So I'll have 6i minus 5i squared all over negative 1. I'm going to go ahead and make it negative 1 because I squared is negative 1, I times I is negative 1. So just saves me some rewriting. But on top I have 6i minus 5 times negative 1 all over negative 1, which is the same thing as 6i plus 5 over negative 1. When you divide this by negative 1, you just kind of change both signs, so you have negative 6i minus 5. That's as far as we can go, so that's all we need to do. Hopefully this has helped you guys out with complex numbers. Thank you again for watching, and I appreciate your time.